Hello and welcome to yet another video of your quality math channel, Cornerstones of Math. Today we are going to solve the following problem. Consider circle O with radius 1. An isosceles triangle ABC with AB equals AC circumscribes this circle as shown in the figure. Find the minimum perimeter of the triangle ABC. Okay, first let's introduce some variables. Let this length be x, then this length is also x. Also, let this length be y. We need a new variable here. Then, what is this length? Well, by the Pythagorean theorem, you can easily find that this length is square root of y squared plus 1. Now we can find the relation between x and y by applying Pythagorean theorem again, this time on triangle AHC. So we have x squared plus length of AH is 1 plus square root of y squared plus 1 squared equals AC squared, so x plus y squared. So x squared plus this part is 1 plus 2 times square root of y squared plus 1 plus y squared plus 1. And right hand side is x squared plus 2xy plus y squared. So x squared and y squared cancel out. So we have 2 square root of y squared plus 1 plus 2 equals 2xy. And if we move this 2 to here and divide both sides with 2, we obtain square root of y squared plus 1 equals xy minus 1. If we square both sides, we have y squared plus 1 equals x squared y squared minus 2xy plus 1. So 1 cancel out. And x squared minus 1 y squared equals 2xy. Now obviously y is non-zero, so if we divide both sides with y, we have x squared minus 1y equals 2x. And now if we want to divide both sides with x squared minus 1, it must be guaranteed that x does not equal to 1. Considering this figure, you know that this length cannot be 1. So back to here, we have y equals 2x over x squared minus 1. With this, we can express every length with only x. Now it's time to calculate the perimeter of the triangle ABC. So let P be the perimeter of the triangle ABC. Then you can see that P equals 4x plus 2y, from the figure. So using this, we have 4x plus 4x over x squared minus 1. So we have 4x cubed minus 4x plus 4x over x squared minus 1. So these cancel out each other. So we have 4x cubed over x squared minus 1, which is defined when x is greater than 1. In order to find the minimum, let us take derivative. And we have to use the quotient rule here. So by this rule, we have the derivative of the numerator, which is 12x squared, then the whole denominator, x squared minus 1, minus the whole numerator, 4x cubed, and the derivative of the denominator, 2x, over denominator squared, so x squared minus 1 squared. So we have 12x to the power 4 minus 12x squared minus 8x to the power 4 over x squared minus 1 squared. So we have 4x to the power 4 minus 12x squared over x squared minus 1 squared. So we have 4x squared minus 3 over x squared minus 1 squared, defined in this range. Right, from this expression for the derivative, you can easily see that the derivative becomes 0 when x equals square root of 3. And the sign of the derivative is negative here and positive here. So the function decreases here and then increases here. And you can see that the perimeter P becomes minimum when x equals square root of 3. Therefore, the minimum value of the perimeter P is 4 times square root of 3 cubed, square root of 3 squared minus 1, which is 6 square root of 3. So this is the minimum value. Also, notice that y, which is given like this, becomes 2 times square root of 3 over square root of 3 squared minus 1, which is 2 square root of 3 over 2, which is square root of 3. Therefore, we have x equals y when the perimeter is minimum. That is, the perimeter is minimum when the circumscribed triangle ABC is an equilateral triangle. And that's all for this video. Thank you for watching, and I will see you in another video.